Hello dear students, in last two videos we learned about the group code, coding theory, minimum distance and Hamming distance. In this video we will see problems on detection and correction of errors. So let us start with the example first. So in this example we have 3, 4 parity check code, means we have function e from b cube to b raised to 4, and for given code words we have to determine whether an error will be detected or not. So firstly I just revised the what is parity check code in for 2 words only. So suppose e is a function from b cube to b raised to 4. So image of 1 0 0 is, so first 3 letters as it is, and we have to find the fourth word. For that firstly we find the Hamming distance of 1 0 0. So Hamming distance of 1 0 0 is a 1 and which is a odd. So for odd number we put a 1 in the last place. Similarly, if we apply e's function on 1 1 0, so image is 1 1 0 and last word is 0 because Hamming distance is 2 and which is a even. So basically from this example we can conclude that weight of code word is always even. So you can see for images, this is code word means the images. So in images the number of ones should be even. So consider the example 1. So for example 1 0 1 0 0, for that word the weight of that word is a 1 which is odd. So this is not correct. So for this 0 1 0 0 we can detect error because there is a odd number of ones. So we can detect the odd number of errors. Similarly for example 2, so 1 1 0 0 there are even number of ones means 2. So if we detect the even number of ones, so we can say that code fails to detect an even number of errors. So from this example we conclude or we get a note that odd number of errors can be detected, and if received word means image has an even weight, then we cannot conclude that the code word was transmitted correctly. So I hope you will understand. Now next most 2 important theorems in a coding theory. So first theorem tells that if we have encoding function e from b raised to m to b raised to n, and that function detects k or fewer errors if minimum distance is at least k plus 1. That means we have a condition that k plus 1 is less equal minimum distance. So that function, so next theorem is second theorem tells that if e is a function from b raised to m to b raised to n, and that function correct k or fewer errors means k or less than k errors if it is necessary that minimum distance between any 2 distinct code words is at least 2k plus 1. So we can write this as mathematically as 2k plus 1 is always less equal minimum distance. So we can detect, so we will see example of these two theorems. So let us consider the 2, 4 encoding function, and we have a function, we have an encoding function e as b raised to 4 b square to b raised to 4, and which is defined as a given below. So given that e of 0 0 is 4 times 0, e of 1 0 is 0 1 1 0, e of 0 1 is 1 0 1 1, and e of 1 1 is 1 1 0 0. So for that function we have to detect the errors. How many errors can e detect and how many errors can e correct. So firstly we take x0, x1, x2, x3 as images. So we put x0 as a 4 times 0, x1 as a 0 1 1 0 and x2 as a 1 0 1 1 and x3 as a 1 1 0 0. So for next step is we have to find the minimum distance. For minimum distance we have to make a distinct pairs. For distinct pairs how many choices are there? So we can find with the help of combination function. So in combination function, so how many combinations are there? So we can find by using the NC2, means there is a function, means there are 4 images or 4 code words. So from 4 code words we have to make a pair. So for that there are 4 C2 choices, means this is 4 factorial divided by 4 minus 2 is 2 factorial and 2 factorial, and this will get us 6. So we can make a 6 distinct pairs, and that pairs are x0 x1, x0 x2, x0 x3, x1 x2 and x1 x3, and last one is x2 x3. So after finding these distinct pairs we have to find the XOR function. In last video we learned about the XOR function. So x0 XOR x1 is, so 0 XOR 0 gives us 0, 0 XOR 1 gives us 1, 0 XOR 1 gives us 1, 0 XOR 0 is 0. Then x0 XOR x2 gives us 1 0 0, because 0 XOR 1 is 1, 0 XOR 0 is 0, 0 XOR 1 is 1 and 0 XOR 1 is 1. Similarly, we can find the remaining 4 distinct pairs. So after finding the XOR function, we have to calculate the weight of these distinct pairs. So weight of this x0 XOR x1 is 2, because this code word contains a 2 number of ones. Similarly, weight of x0 XOR x2 is 3, because this code word contains a 3 number of ones. Similarly, next weight of x0 XOR x3 is 2, because there are 2 ones. Weight of x0 XOR x2 is 3, because there are 3 ones. Weight of x1 XOR x3 is 2, and last one weight of x2 XOR x3 is 3. So after find the weight of all distinct pairs, so last step is we have to find the minimum distance. So minimum distance is we take a minimum from distinct numbers, distinct weights. So distinct weights are 2 and 3 only. So minimum from 2 and 3 is 2. So we get a minimum distance is 2. So next step is we have to find the how many errors can E detect and how many errors can E correct. So from previous theorem, so first theorem tells that detection of errors. So how many errors can E detect? So clearly E detects k or fewer errors, and which is equals to minimum distance. So for sake of convenience we take a equality sign. So this is k plus 1 is equals to 2. After finding we get a k equals to 1. So we can say that encoding function E detects 1 or less errors. Similarly, we can use a theorem number 2 for correction of errors, and this theorem we saw that encoding function detects k or fewer errors if minimum distance is at least 2k plus 1. So for again sake of convenience we take a equality sign. So 2k plus 1 is a number of minimum distance. So after solving this we get a k equals to half. So can we say that E detects half number of errors? So no. So E cannot detect, in that case E cannot detect any error, or we can say that E corrects 0 errors. So this next example is for your homework. So you can use this example and try to solve the detection and correction of errors. Thank you.